Okay, dug out a new bush, the old new bush. And what did I do with the original old bush? And their old bush. Oh, look at that. Maybe that's the difference in height between them, huh? It's about how much that was sticking up too tall, wasn't it? Yeah. That means I didn't cut this hole very deep. So roughly about 3/4 inch deep. So that means that should be 3/4 inch deep right there. Actually, it should be less than 3/4 inch. Oh, yeah, it is. It's 710, 50 thou less. That'd be the clearance built in. This one, on the other hand, was too tall. .774, showing 15 thou, too tall. It was sticking up more than 15 thou though. So probably has a different. Oh yeah, there's a big difference in chamfer height too. See your chamfer height right here versus this one. It's a little shallower. Alright, either way we're going to cut this down to 710, so we're going to cut a 1/16 off this sucker. And then it should be able to go in the hole all the way to the bottom and do what it's supposed to do. If we're lucky. We haven't been too lucky lately. So there's a lip there. There's a double lip. 726 is the first cut. Yep, that's about how much it was sticking up. So there you go. So we need to be under 726. So 700 would be a good number to cut down to, just to make sure. But yeah, 710, 700. I can live with any one of those numbers. All right, so now we get to go over here to Lathe and turn this sucker down. So that's why you got to pay attention to what you pull out sometimes. These reproduction parts are not made correctly a lot of times. One that costs a lot of time and money to correct it, which is where we're at. A lot of time, a lot of money. Good clamping surface, that outer flange, but that's all we got to work with. Tells you how much you're cutting. Do light cuts. You want to whip it out. No more than 5 thou. Of those, 60, and get down to where we need to be. Trying to get it a little straighter, but oh well. Don't want to be straight. Alright, 65, that'll be enough. We only need probably about 35 or so for sure. We have it. OID. Put a channel for the OD by filing. It's not square. Oh. Alright, put a couple burrs in there. Knock those down. Alright, should be about 715 or so. 790. How are we at 790? Oh, wrong dimension. 714 and a half. Not quite 715. What if I measure on this side? 718. 720. Depends on how you measure it. If you're a little bit off your angle, you get different numbers. We're about 720. Close enough. Alright, so we got our number in there we want. Should be able to put that in there no problem now. They're nice and tight, we already know that. Because we already beat one in there once. Okay, let's get all our marks on here again. Going to mark our feed hole here. Going to mark our dowel pin hole over here. That's a no drill zone. Always go over the edge a little bit. Sometimes it gets covered up by the bushing. And this one over here, we're going to mark our oil hole here. So we know exactly where it is. Not that we can't see it anyway, but it doesn't hurt. Let's see, this was the one reason, 4500, 10,000 Phillip, high temperature, high pressure. There's lots of different Loctite retaining compounds, so this is a maximum ohms power. 4500 tensile is pretty stout stuff. Red Loctite's like 15 to 18, about 1800 I think they rated at. It's hard to tell, they don't really tell you even numbers so you can correlate real quick. They like to use different standards so you don't know what the hell you're doing. Kind of like motor oil and gear oil for viscosity. They're not even close to the same numbers. .80 weight gear oil is like 20 weight motor oil, but numbers are almost the same, right? So to keep the Loctite away from the hole, we need to be putting Loctite into our hole. Okay. Let that sucker up. Turn that off for now. Okay, it all looks good. Got our beating tool here. Sideways. There it goes. Popped in there straight now. Oil hole shifted slightly, but it's close enough. All the way down. We missed our hole a little bit, but not enough to worry about. Appears to be all the way against the surface this time. Good deal. You can still see the oil hole through in there, maybe. Not sure if you can see in there or not, but I can. If you want to double check it, you put air to it and you blow air through it. If air goes through it, oil will go through it. So let's go over here and blow the air through it. Loosen my finger. There's the airflow coming out of it. Okay. Works like a champ. Success. What a shocker. I wonder if that hole goes through. I was trying to see if that oil hole goes all the way through or not. It's hard to see in there. Yeah, we can double check that one too. I ain't feeling that one. Oh no, it doesn't go through at all. It's solid. Alright, it's a good thing we checked that. That's what's known as being non-functional. Kind of important that actually goes through. Otherwise it hydraulics the crank in the left side thrust washer and burns up the thrust washer in the case because it's a floating crank. So that hole needs to be drilled through there the rest of the way. Ah, good engineering. See how they drilled through the bushing? See, normally you drill a hole in a cover down below the height of the bushing. You don't have to drill through the bushing for the oil hole to go through. But see, V-twin didn't make their part right. Alright. Yeah, nice of them. Good deal. Really good job. Okay, we're going to make our dowel pin here for this. Where is my other one? I need two of these long ones. These are 1/4 inch long, not those little short 3/16 ones they were using in stock. V-twin was used saving money on their pins. Okay. So there's two of those. Yeah, I don't need to have those over here. What I do need is scale and a little small drill bit. I think we put it away. We're also going to have to drill this down here deeper, which is about the same size bit it looks like too. So, find us a drilling apparatus. Let's see here. Drilling apparatus. It'd be like one of these. Shoot it over here and find ourselves a drill bit. Drill bit. $120. Looks like it got put back in the thing here. There's our 120 we need. And 126 is the next one up. That's 125 looks like. Alright, we'll use our 120 drill. They actually use an 1/8 inch drill bit in there, looks like, so we'll go ahead and use the same one that we're going to drill everything else with, I guess. Okay. Need some power around here. Right there's power. A lot of power. Maybe we'll just hand drill it. Find the angle that they had it before at. Do not drill through the cover. Definitely drilling hard. Alright, we are going to go see. We're not drilling too deep. Take this row show to the other side of the shop. We need an airline. I don't want to drill through all the way, that's the problem. Doesn't go through yet. You look down the hole in there. Right in there, you can still see brass in the bottom of the hole if you get the right angle. I can't see in the camera what you're looking at, so I am not deep enough yet. But we're getting there. So we'll just keep going a little deeper until we get all the way through it. Still brass, but it's getting a lot of aluminum down there too. Whoa, she went through. All right. Goes through now. So you can see how it goes in there. If you look in the bottom of the hole down there, you can see the drill bit in there. So it's in there. Wedge is in there too. There it goes. So she now has oil. Definitely not a good design. Right. Clean this up, we'll be back.